Hey y'all, in today's video we're going to take a closer look at catalysts. We're going to look at both the different types of catalysts as well as how they work and their impacts on the rates of chemical reactions. So let's go ahead and get started with the most fundamental understanding of catalysts. Catalysts will increase the rate of a chemical reaction by increasing the probability that any collision is effective. It can do so in one of two ways. Either it can lower the activation energy of the transition states, or it can improve the likelihood of suitable orientation for a collision to occur. Many catalysts do this by actually changing the entire mechanism by which a reaction will happen. So oftentimes when we look at introducing a catalyst to a reaction, we're not just speeding up the reaction, we're fundamentally changing the process by which the reaction occurs. So instead of taking the same transition state and stabilizing it, we're essentially creating a whole new transition state in this process. We've already talked about how catalysts can be shown in mechanisms. They appear at the beginning and then again at the end and are used in the process of the reaction. And so for that reason, in general, we can think of catalysts as being of constant concentration during a reaction itself. But that doesn't mean catalysts will always be of constant concentration. Catalysts can increase concentration or decrease concentration and have varying effects. That means that more catalyst might increase the rate. That means it's in the rate law, which if we use our techniques to write the rate law of predicted mechanisms, catalysts are going to be there. They're going to be in the predicted mechanisms rate law. So let's look at how a couple of different types of catalysts can work. The first catalyst we're going to look at are biological enzymes. Now, if you remember back to biological enzymes, they have the lock and key process. Now, by lock and key, what it means is that these substrates come into an active site on the enzyme, they bind to the enzyme, and then react. Well, think about it this way. In order to bind to the active site, they have to be in the correct orientation. By having a biological enzyme present, it ensures that when the two molecules of the substrates come together, they do so with suitable orientation for the reaction to occur. So biological enzymes use a very specific shape, hence why denaturing an enzyme makes it ineffective, and that shape is going to ensure that the orientation of the substrate molecules, the reactant molecules, are perfect for the reaction to occur, which is going to, again, minimize the or maximize the likelihood of suitable orientation, thereby increasing the K value, thereby increasing the rate of the reaction. There are other catalysts that act in a secondary way. In this way, the catalyst might actually create a whole different intermediate. So basically, they bind to one of the reactants, create an intermediate that is fundamentally different than the original reactant, and for whatever reason, that intermediate is more likely to react with the secondary reactant. Okay, it's actually really common in acids and bases. So acid-base catalysis is a very common process by which this occurs. So basically, the catalyst itself is going to bind to one of the reactants and make a new intermediate that makes the second part of the reaction, the second part of the mechanism, more likely to occur. The final type of catalyst is actually a really interesting one. And this is going to be one that occurs at the surface. And oftentimes this is going to involve metals. So we actually have many of these in older cars called catalytic converters. Now, catalytic converters are made of metal. And in this metal converter, what it does is it fundamentally speeds up the reaction by which many of the polluting molecules that are emitted as exhaust from our cars are broken down into less harmful molecules. So in this case, the molecules have to collide directly with the surface in order for the reaction to occur. Okay? And again, it's just a slightly different process by which this is going to happen. We can also categorize catalysts as homogeneous or heterogeneous. And basically the premise of a homogeneous catalyst is that it simply takes the same phase as the reactants. So if the reactants are gaseous, the catalyst would be gaseous. If the reactants were liquid or aqueous, then the catalyst would also be liquid or aqueous. Heterogeneous catalysts are those that take a different phase. So we just talked about the surface catalyst. That's an example of a heterogeneous catalyst where it's a different phase than the reactants. So if the reactants are gas, the catalyst might be a surface of metal on which those reactants can actually react. Normally, heterogeneous catalysts are solid, while the reactants are gaseous, aqueous, or liquid. So that wraps up today's video. Today we took a slightly deeper look at catalysts. We talked about the different types of catalysts, the different categories of catalysts, and the effects of catalysts. Remember, the fundamental understanding is that catalysts lower the activation energy of a reaction. They can do so in a few different ways, but fundamentally speaking, they're normally going to create a new mechanism by which the reaction will happen, normally with a more stable transition state, and often these reactions can occur in a way that is creating either more likely effective collisions due to suitable orientation or more likely effective collisions due to lower activation energy. Biological catalysts, like enzymes, mostly use suitable orientation, whereas solid-state enzymes usually go the other direction, which is stabilizing transition states. That also wraps up this unit on kinetics. Remember, kinetics is fundamentally about the rates of chemical reactions. And when we're looking at rates of reactions, there are a lot of things that can affect rates, and there are ways that we can determine experimentally the rates of different reactions. We need to make sure to keep in perspective the fact that kinetics is all about experimental, empirical evidence. In the next unit, we're going to start looking at how kinetics impacts the processes of equilibrium, which we've already touched on a little bit in this unit, but we're going to go deeper into equilibrium in the next unit. I hope you enjoyed this video, and I'll see you in the next one.